You joined.
Just for our purpose, like for recording.
Get a couple more coming in.
Yeah. Come on in, folks. There is space in the front. We don't bite you.
Chetton doesn't bite.
Yeah, I think people will trickling. We can get started. It's 1:30.
All right, awesome. Well, hey, we'll get started, gang. Can everybody hear me fine? My name is Ben Westmoreland. I'm part of Insight Enterprises. And Chetton and I are going to be talking today on some API frameworks that we leverage quite often, REST, GraphQL. Across a lot of our projects, talks about some of the advantages and things that nature, right? So this is intended to be, I don't know, maybe 400 level level conversation. We're going to review some basics and get into some pretty good examples here that we're focusing on. And then I'll talk a little bit around some of our customer stories and how we're implementing this. And Chetton and I are pretty fun dudes, so let's make this interactive. Try to chop this, and
Yeah.
close off, whatever you want to do. Chetton is my lead for Java across our entire enterprise, but I am a .NET guy. Y'all gonna throw stuff at me. But again, Ben Westmoreland, I'm our COE leader across all of our service lines. So Insight Enterprises, we focus on modern application services, data and AI, modern cloud, platform engineering, digital enablement. We have full infrastructure. We're full SI partner. About 12,000 people globally, and manage close to 34,000 in cloud.
Yeah.
Get us. There we go. So anybody in this room has never touched or written an API. So it's really the foundation of everything we do. I've been like 20, take myself here, like 25 plus years. I did a lot of stuff in BizTalk and other things, integration of solutions. But the way that we do that is key, in understanding these different frameworks, use cases on where to leverage, REST versus GraphQL, gRPC is something we foundationally focus on at any given point. So let's break that down a little bit. So REST been around for a good long time, I think for 2000. Typically going to use JSON these days. You still have a lot of legacy solutions that use XML. Very flexible, probably the most predominant, framework out there for API integration. But, does come with some challenges. Typically we're going to see that your API calls, you can overfetch as your data grows. We'll have some examples of this. You can get large calls and a lot of latency, issues on performance, right? When you start to scale some of your systems. Also, it doesn't support any streaming type of.
And just an FYI, all these slides are available in GitHub.
Yeah,
the slides will be linked.
We'll have a repo and everything for you guys.
Yeah.
Yeah, exactly. Oh, what are you doing? You're trying to rush me already. Yeah. GraphQL. So GraphQL, I'll say go back to REST. So standard across a lot of our applications, 90% of what we do, we're going to see REST. We're going to run across it. We're integrating with any existing SaaS solutions or any legacy type solutions. It's all going to be REST based. So predominantly, what we see in our enterprise development is going to be REST. GraphQL, though, something as we're modernizing systems or developing, we're leveraging quite a bit. So GraphQL, the advantages here, still leveraging your JSON and your data format, right? But it allows that dynamic query, so you can really kind of query what you're looking for. This is primarily, I'll give you a use case that we're working on right now. We have a client that is built a SaaS component that will allow their downstream clients to kind of query for their data, right? Specifically what they're looking for, from a reporting standpoint. So that allows you, from that standpoint, to be able to actually specifically query for what you return, right? So it's pretty efficient, and that's really the advantage on GraphQL. Now, gRPC is probably our lightest use, but we're starting to heavily use it, mainly in two spaces for us. We cover a lot of verticals, so everything from retail to healthcare to manufacturing. Right now, a lot of my clients are on Fire's manufacturing space, so we're doing a lot in IoT. We're doing a lot of edge type components. And gRPC for us is becoming, a big stake there. Mainly because we can, run APIs against these solutions to be very highly performant. We're usually bi-directional kind of streaming concepts, but mainly the data is it's more than you're not doing a text base, and so you're very strongly typed data and can be very performant, right? But out of those three, so REST, generally we see 90% of what we're doing. GraphQL is picking up quite a bit, and gRPC is newer for us on them. What we got here? All right, so we're going to jump in. Let me describe a sample that we're doing. Somebody smarter than me. Some code. That's what you're really here for. So let me lay the our data model out here. So Chetvin's going to be giving an example, and we've got the starships example, many relationship here. So if you think about all the starships, you're seeing all the cool films you got. In those films, it's a many-to-many relationship, and then the producers, it's a many-to-many relationship. So pretty simple data set concept. So when we break that down, if we look at the REST API, if you were able to call and get, you can call your starships by ID and get a simple response back. Nothing wrong with that. But what happens when you try to get that same set of starships from, from a film? So in this case, the second example, we had a Star Trek, the ships. As you go along through the season, that list gets longer and longer. So that's what we're talking about. Like your data, you can't control, how much data you really have. When we actually compare it to the graph, we can actually be very precise about it. And gRPC is all, in this case, we're doing a get films, and it comes back in a binary, so it can be a little bit more performant. So again, just to hit on these real quick, we have the data formats that are returned. We think from our development team, learning these things from junior developers all the way up, REST is easy. Finding gRPC is pretty long. GraphQL is a little bit more challenging for some of our developers. Community for these, REST is very, very large. We see again a little bit more growth in GraphQL, and gRPC is on the uptick. Okay, so I'm going to let you take over and do a demo now.
Let's see some code now. Let's go back to our IntelliJ. So let's okay. So let's go to the first one. Like as Ben already mentioned, let's quickly go over the schema of what we are dealing with. So because it always steals, solidifies when we have a real world example, like how we are working on. So we want simple example, but not too complex that it's going to take 30 minutes just to explain what we are talking about. So it's simple like Starship. It has these IDs, films, ID and title. Like as Ben mentions, many-to-many Starship films, film ID, Starship ID, foreign key. And then films have a producer. It has just name and an ID. Same again, film to producer. So we can see the graph. Like there are three independent entities, Starship, films, and producers, and they are linked with one another. It's good. And just for clarity purpose, I just loaded some dummy data in it. Like there are some Starship films, producer films. So that's our data model we're going to work on. All right, so let's fire up our application. So just so that I create my demo gods and don't want to overcomplicate it, everything is going to be in memory. So that I don't want to connect to any fancy database. Everything's going to be H2 database. Nothing fancy going on. All right, let's do some role play. Venkat, I'm going to pick up on you. You're going to be a UI developer, okay, for this session. All right, so let's see. So you're going to build a UI. So I'm a backend developer. You're going to come and ask me, hey, I want to display nice starships. All right, so let's do. I'm going to go in the backend. Like we all did this every day in, day out, right? We're going to go to REST. I have a nice Starship controller, like all the Spring MVC way. I have a repo. I have a Starship repo, film repo. Venkat comes and asks me, okay, give me all the starships, okay? And you create a nice get endpoint starships and say I get all starships. Cool. Now let's see. I'm going to return him a JSON. Not yet. Starships. Let's print it pretty. Cool. So I have name, max speed, length, everything looks nice and dandy. Venkat builds a nice UI. Cool. Now, like a few months goes by, and then he comes back to me and saying, okay, hey, what about just Starship? I want to display all the films that this Starship appear in. Great. I have already, it's so easy. Like I have another one, Starship ID. I add a film, I add a films. Okay, nice. So let's take, say, this CR90 Corvette. So like our regular Starship, I add /1/films. And then ID1, ID6, I get and show all the films. And then suddenly Venkat freaks out. Hey, what happened to the Starship name? Where did that go? I said, hey, you already got that in the Starship. You want me to send it again? Yeah, because that's a new endpoint. I didn't store anything from the previous one. You see how it's going? Like you have to send either the UI to store it or like to create one more. Let's pick on someone else who I know. Shanika, I pick on you now. Don't sleep back there. So she comes back to me and then saying, okay, it's good that, okay, you give Starship and then give films on it. I want to go other way around. I want give a film ID and give me all the Starship that appeared in that film. And then I go back and saying, okay, I need to reverse it. So let's see, I'm going to go back to my data model. I'm going to create an endpoint called films. I'm going to add an ID, and then I'm going to create a producers for it. And then I'm going to say, okay, Starship films, film one, and producers. Again, it's the same logic. Like if I add this logic inside, tomorrow Venkat comes and says, okay, even I want those films and producers. How do I get it? I don't want to make like 5 endpoints just to render one UI. So this is like kind of, we are hitting the limitations of REST. You hit an endpoint, you get the data, and the same data is going to be sent to everyone, unless you have like versioning, things like that. So that's where like the GraphQL comes in. So like now we see what the problem is. Now let's see how GraphQL fixes it. Any questions so far? Cool. All right. So before we dive into like how it fixes it, like now we know like what we want to achieve. Like we want to have a one endpoint which will satisfy both Venkat and Shanika so that they can display on the UI however they want to. So with that, everything starts with a schema GraphQL. So let's see how this one shows up. So I'm going to create something called a Starship, and I'm going to define what all attributes it has. So first thing is going to be have an ID, name, max speed, and length. I'm going to pretty much dump whatever I have in my repo. So I have all starships. I have films. I return all the films. Film is again a complex object. Let's see if this works. So again, films has ID, title, and producers. And in producers, if I go again, it has ID and film. So this is how I create like, okay, one output is just all Starship, and then get everything. And then same thing, all films. And then these are all the data types. All right. So these are all the queries I support. Right now, you can get all the Starships. You can get like Starship by ID. You can send an ID and get particular details on that. Or you can get a film by ID. Say, for example, if I want, like, that's what Sanika wanted. Like if I send a film ID, get me all the Starship that it featured in. Like all the films. Like if I go to all films, it already has starships and producers. So that's your schema definition. And luckily, Spring also supports it. If I go to my pom.xml, if I search for GraphQL, not a test one. Yeah. Similarly, how we include like JPA and like web and things like that. All we need to do is Spring Boot Starter GraphQL. So this will introduce everything what you need. And let's see the little bit more wiring. So first step is define your query. Second step is like just for my debugging purpose, I just enabled a GraphQL debugging. And there is something called as GraphQL. So this will help you to build the queries like as and when you do it. And that's this, you don't want to enable this in production, but just for demo purpose, I enabled it. So that's the second step. Third step is like, okay, now you did all the dependencies, all the configurations. Now, how would you wire it? Let's look at that code. So Spring Data GraphQL. There is a mapping called query mapping. So this is what like how you have like REST controller get mappings. The Spring has something called as query mapping. So what this one does is you can specify name if you want to. It's like similar like how you can specify get mapping and then name for it. Or whatever the name of the function is, that's what it should match. So if this ID IntelliJ has a nice way of going back. So okay, now I have Starship. Like if I go back to like say show navigate to GraphQL schema, this is what it's going to satisfy. Same thing for everything. I need to have a corresponding function, like say Starship. Let's see if I go. Oh, there you go. You can go back to the implementation. For each query mapping, I need to add, and then argument is going to be the Starship ID. Same thing like film by ID and then query ID. And then you can do mutation, but we're not going to cover it because if we have time, we're going to cover it. You can do mutation, but in our client projects, we haven't seen doing like mutations and doing post requests with GraphQL. GraphQL is mainly for pitching the data. Post still remains the way of submitting the data to back to the server. So, all right, let's go and look at the UI. So this is a nice UI, what it already the library provides it. So everything starts, so there are two ways. If let's see if it shows now. Yeah, either a query, mutation, or subscription or fragment. So we are concerned about query and mutation. So let's start with a query. So you start with a query. Let's go back here. So Venkat, going back to your example. So all you wanted is the Starship, right? Okay, I'm going to give you also Starships. Okay, what all do you need? I need ID, obviously. Okay, just the ID, hit center, you get all the IDs. Suppose if you want, like maybe now I want film names. Let's add name to it. I don't want like max speed or anything of the set. All I need is string name. And then Shanika comes back, hey, I also want this, but I don't want like the max speed. I just want the film names. Okay, so I'm gonna add films. Okay, and then I don't care for the ID. Just give me the title. Cool. I just give you title. It gives me the like in a JSON structure, like 99, and then things is like that. So now you can see like, okay, with just one query, whatever you want, like both Shanika and Venkat can get the same in only the information that you need, only that information you're gonna get from the GraphQL. Yeah. Yeah. So it is using this. No.
Questions? Yeah.
Yeah. Yeah. So it is using a JPA repository. So if I go back to my data, so it's pulling all this data here. And if I record repos, like all Starship repo, all I'm doing is just simple JPA repository, extending it. And then in my controller here, like let's say in all Starship, all I'm doing is repo.find all. Yeah. Can you repeat your question? Exactly. So so it depends on how you implement it. Right now, like if I see in the all Starship, this if I see this all Starship, it returns everything in the Pojo. So and then GraphQL sees, okay, the UI only requested for these many entries. I'm going to return only those. So it depends on how you implement the service. Just for simplicity purpose, I'm returning everything. And the GraphQL decides, okay, I requested only for ID and name. I'm just going to return that. Yeah.
Any Spring data is good enough, or does it need to be a JPA?
No, any Spring data is good enough. Like, I mean, like if you look at this implementation, right, it's a simple Java function. However you want to implement it. Mm-hmm.
You define the repository that usually is the primary key.
Mm-hmm.
And if you are requesting Starship, versus something else.
Mhm. Yeah. So for example, like if in my query, if I want this one particular query, yeah. So for example, for that, I don't need to specify all Starship. I need to go, let's clear this one. Yeah, good question. So I want to query only one Starship. Like in REST, it was pretty straightforward. In path variable, if I go in here, I just need like send a path variable as one, and then you get the corresponding Starship, right? How do you do that in GraphQL? Is that your question?
You should add
Mhm.
index.
Yes,
Index on something other than
ID. Yeah, I've seen some implementations where what they do is like instead of using a database, they use like an like Cassandra or Lucene behind the scene. They index all the things, and then whatever the query comes in, they send it, and then the result is sent back to the client. I've seen some implementations among that.
no SQL.
Mm.
You should be, if you are offering this, the search based on something else, that should be an indexable.
Correct. Yeah, you should be smart enough to figure out, okay, how it's gonna perform on the back end. Like for example, if let's go back to our, let's say Starship by ID. In this one, if I say Starship ID 1, and then let's come on, ID and name. If I don't index this Starship by ID, then that's going to hit a performance hit. So yeah, I mean, like, so that's the importance one. Like whatever in here, you can specify what you want to expose it, right? So if I go back to my schema, I only specify Starship by ID and film by ID. I didn't specify producer by ID, for example, because that is not indexed. So you can control what you want to expose. So right now there is a limitation. Okay, I have a producer ID. Can I pull the producer by ID? No, you cannot, because maybe like, there's some restriction on your backend. You don't want to pull that. Yeah. Pagination is one. I mean, like in this case, like for example, in here, the exclamation point means, look, okay, I have to have you need to send the parameter. I can add another parameter, okay, limit 1,000 or whatever you want to say. Okay, you have to send how many records you want to back. Or as Venkat said, you can do pagination. That's a little bit low level. You don't want to do that. Obviously, like I mean, let the framework handle it. It's similar to like how you want to like you don't want to like when you do a REST implementation, you want to split those parameters into path variable or query variable so that you don't want to do it manually. But yeah, if you want like go that low level, okay, just give me the JSON what the user sends. I'll do my job. But yeah, you could still do that, but it's not recommended to do it. Yeah. Either don't expose it or have some way of caching it so that you know you want to return quickly. Suppose like if 100 million asks for everything in your database, you don't want your database to crash. You want to have some layer of caching or some layer of faster response time. Mm-hmm. No, not necessarily. For example, let's look at this implementation, like Starship by ID. So let's look and
Yeah, and I mean, and again, this is a very simple example. Like, you know, in the enterprise situation, you want to implement some rigor around that, make sure you weren't overcalling and that kind of thing.
yeah. Yeah. Any other questions? Exactly. Mm-hmm. Exactly. So if like, are you asking about this JSON here? No. Okay. This one. Can you explain what these? Oh, okay. Yeah. So yeah. Okay. So let's start with the Starship. So let's go back to our schema. So how does the Starship look like? It has a name, ID, and max speed, and a length. Okay, these are the bare minimum, like basic attributes, like primitive attributes, not basic, primitive attributes. And it has a many-to-many relationship with star films. right? So that's the low one level down. So how do you represent that in the GraphQL? So I still have an ID, which is this. This is the way of representing this is an ID. And exclamation point means this is a required field. I'm always going to return this field back. Same thing, name, max bit, and length. These all map back to like the primitive objects. Next one, I want to also expose films. So this square bracket means it's an array. And then I'm going to return like one or more films. At least I should return one or more films. And this is also required. And this is like a composite object, like how you have in your Pojo, like, okay, these are the objects. And then I have another film object in it. Maybe it might be easier if I show you like how it's represented in an object. Exactly like this. Okay, I have this, and then I have a list or set of films. No, this is what I define at the entity level, and this is what I expose at the GraphQL level as well. Because you need to have at least one-to-one mapping. Whatever you are exposing GraphQL, you should have a way in your server to return that data, right? Yeah. And then if this is a composite object like float, integer, these are all primitive. And if float, if I don't specify this films here, it'll give me an error. So I'm going to create a new type, like think of type as a class. And this one has ID, title, and then producer is again a list. Again, producers is a composite object. Here it has a name and an ID in here again. No. So this what I say is like, okay, you can't request it. If someone, I'll always return this field back. So if I go to the schema definition, you can say okay, in all starship. When I see the definition, it says, okay, exclamation point means, yeah, if this query is always, this value is always going to be available for you to return if you want to request it. It's a non-null field color. Which one? The graph, this schema? No, this hand wrote it.
That what you do it? You generating any of this normally?
So this one, the scheme, the JPAs are all generated automatically using like JPA buddy. So you could like, if you give the schema definition, it will generate the JPAs. But the GraphQL, you don't want to generate it automatically because as you said, like you don't want to expose all starships. It might crash your system, right? So you want to decide, okay, what you want to expose and what you want to limit.
Like these types.
Yeah, these are all one-to-one mapping. What is it? Yeah, so this like how you for APIs you have like open API definition. So this will the docs will give you like this is all auto generated. I didn't generate all this. So you can see okay what all queries are available. These are all the queries for me available. All films okay I'm gonna get this one. So you need to you need to give the correct Swagger UI, but it's automatically generated for you.
Yeah, I would say though, back to your question though, I mean, this is just a simple example for, we got a varying level of audience, right? So making sure that we got a pretty simple, straightforward answer, but typically in the enterprise settings, and so like this lower level code, we're going to go through code generation, some type of GitHub Copilot type implementation, right? It's typically what we're going to use.
I had one use case on another for GraphQL, and then we can move on to gRPC. So going back to Shanika, so now she's more interested in films, right? So now if I go back to all films, in the same way I can add title, and then it only gets films. I don't care for what starship appear. Tomorrow, if I want to come back and add starships, or like in here, if I just add a name, it'll give me a name for it. Okay, this is the name, and then these are all the starships that appeared in there. So that way you can have only one endpoint exposed, and then you can build multiple UIs on that. So that's the use case GraphQL is trying to solve. So I mean, I hope the takeaway is like we are not saying GraphQL is better than REST or gRPC is better than GraphQL. They are all complementing each other. REST solves one particular problem, GraphQL solves another particular problem. Sense? Yeah. Yes. Yeah, that's a very good point. So like, for example, like tomorrow, if I go back and add another attribute here, so that we will not break any of the UIs because you're not even requesting that new attribute. And whenever the UI is ready to accept that new attribute, they're going to change the front end. In this one, if you remove anything, Like for example, today I'm asking for max, let's say max speed, not in films. Let's say in here, I added max speed, and then tomorrow I went back and removed this max speed. So that means your UI is broken now. So adding is gonna be future proof, but if you remove anything, it's gonna be a breaking change. No, you don't need. I mean, like you could if you want to. Like right now, I just added like if I look in here, if I go back network, when I send it, let's see. Right now, it's just sending to localhost GraphQL. You could add versioning if you wanted to, but ideally you wouldn't need to. I mean, like it is always backward, future compatible. Renaming, changing, removing, that will break. But if you add anything, it's not gonna. I think I saw this before. You mean like you don't want to expose everything? You want to create a separate object and you want to create a separate function for it. Yeah. Two different functions. Yeah, because in this one you're gonna see everything. If I say I don't want you to know the list of producers, you're gonna create maybe all films excluding producer or something like that, and only expose the object that you want to expose. There's another hand thing you have. Yeah, good question. So let's create an error, right? I mean, what's the fun in demo if we don't have any exceptions? Let's create an exception. Let's say I'm gonna request for Starship ID, and I'm gonna request for, let's say 1000, which doesn't exist. And I'm gonna request for name, right? I mean, this is a valid jQuery response. I mean, UI doesn't know that it doesn't exist. What happens then? I mean, right now I didn't handle it. Like if I go back to my server, it says, okay, Starship ID is not valid. So this is you could handle like exception, but right now I'm just saying, okay, if you see here, there we go. Let me close this one. It still returns UI as a JSON, internal error, Starship and ID, and it says internal error. But error handling is going to be the same way as before. I mean, I'm right now, I'm not catching an exception and returning it, but GraphQL framework is smart enough to figure out, okay, this was an 500 error, and it's going to return me a valid JSON back. Any other questions? All right, so now let's pivot to GRAPHQLvsgRPC. Yeah. We do. So it's like any other endpoints. It is like as you know, like it is integrated as a Spring framework. If you have Spring security on your class path, it will by default like authorize. It has to be authenticated. So you could add like a security filters to allow or not allow based on the endpoint. Because end of the day, it's an endpoint which you're going to reach, right? I mean, if I look into it's gone. Okay, let's add it here again. Yeah. Yeah. Like end of the day, it's an endpoint what you're controlling. So as long as you can authenticate, yeah, you should be able to reach it. Anything else? All right. Yeah, this is the query name. You could, yeah. Like for example, if I look at the payload, yeah, there you go. So the query has the Starship ID in here. Yeah, you could filter, go further down on that. No, that's the advantage, right? Going to as a GraphQL, you don't want to have the function name as part of the URL because then that means it's going to be unique per request. Then it means if tomorrow if I want to add something else, the URL has to change. Versus if I can add a function, okay, so you keep the same URL, only the payload is going to change. That's going to be on the server side. So everything is going to come at one place. And then from there, if you want to have a different router, okay, you can query the payload and see, okay, if it is the query starts with Starship ID, go to this service. Like for example, in microservices example, like, okay, Starship is handled by one service, Film is handled by another service. So in your router, in your gateway, you can specify rules. Okay, if this query goes to this service versus this query goes to that, but everything is going to hit to that GraphQL header. So if I go back here, everything is going to come to this endpoint. All right, now let's go to gRPC. So Venkat, you're gonna wear a different hat now. So you are not a UI developer, you are an edge developer now. All right, so now let's see what problem gRPC cannot solve. I mean, one obvious problem is there is so much data, like, I mean, so much payload in it. You have so much JSON and there is like so much overhead. Imagine you are developing, like, let me give you a quick story. Last week, I visited Disney, and then like there was like a lightning pass where you can book only 3 rides at a time. So once you scan a batch in a ride, immediately it's available for you to go to book and book next ride. So if you want to given the problem, how would you solve it? So ultimately the where you scan your batch or that magic band, that should communicate to the server and tell, okay, this ride was done by this server, this person, and then now they are available for doing the next ride. Imagine doing a REST endpoint or maybe GraphQL. So, like, first of all, that magic band, like, or the IoT device is so small, it cannot handle so much memory. It doesn't have so much processing power. All it needs to do is somehow communicate to server, okay, this person ID and this ride ID was done by this person. All it needs to do is just maybe like 2 or 3 information, send it to the server. So for that kind of scenario, REST and GraphQL are kind of overkill. Can it be done? Yeah, it can be done, obviously. But is there a better way to do it? So that's where gRPC comes in. So let's go in that. Waiting on time, guys. So like similar to like how gRPC we did, like GraphQL we did. So we understood what problem we want to solve. Now let's look into the technical details, like how to implement it. So let's continue with the same Starship example. So the scenario is I'm a client. I suppose like the Starship and Films is a very huge data, and then I don't want to wait for it to come. All I need is just quick send an ID and get it back. How do I do that in gRPC? So it is a little bit more complicated. There is a little bit more steps involved. So let's start with the first one is there is something called as protobuf. Similar to like how we had in GraphQL, we have similar in gRPC as well. Like you define your services, you define your endpoints in something called as .proto.
Who here knows what a protobuf is, or who knows who developed it originally? I heard it somewhere. Google.
Yeah,
Nice.
yeah.
I got some sharp people here.
Yeah. Java is smarter than .NET, right?
Yeah.
All right. So this is going to be a specific to Java, but like as you know, like protobuf or gRPC supported by it's almost 10 to 14 languages: Python, Golang, .NET. Yeah, they do support .NET. See. So and then this is like specific to Java. Okay, I have like multiple files. You don't want everything dumped into one file. Like what packages to use, what class name to use, and like what prefix, things like that. Let's see. Okay, I want to implement the same all Starship info. If I want to implement in gRPC, how would I do that? So in here, let's see if I can just side by side, I can compare it. So this one we started with, okay, type all Starship and then added my attributes and films. In the same way, if I go back here, I have, so think of it as like a report procedure call. All I'm doing is look, it's going to look as if I'm calling a local function from a jar file. So all I'm going to do is like, it's going to be a streaming just so that I can show you like how streaming works in gRPC. I'm returning all Starship data. So what is all Starship data? It's the same thing again. It's an integer, string, float, and then like how we had an array representation here. We're going to have something called as repeated. I don't know where I'm getting the static. It's called repeated. That means it's a looping array, and it's a for Fojo. And then this number represents, okay, what order it's going to come in. And then to think of protobuf as similar to Java serializing, where you're gonna the serializing object is not human readable, right? I mean, when you serialize an object, it's not gonna be, but it is pretty compressed and it is fast to transfer over wire. That's the point. But protobuf, if when you see it, it's not gonna be human readable, but it is language agnostic. So whichever language, suppose a client is in Java and then server is in .NET, they still can communicate using protobuf. And then same thing like all films, and then films is going to be ID, title, and then producers is going to be repeated again producers, and producers is ID and name. So this is the structure of protobuf, how it looks. Any questions on this one? Yeah. Yeah, good points. So there are 2 answers for it. So currently, if you want to do something in production, this is the way you need to do. But if you can wait 6 months, Spring is still, let's quickly open this one. Spring is supporting, but it's not GA yet. If I go to Spring gRPC, it's still in experimental phase. So it's not GA yet, but eventually in few months, it's going to become GA. But what you can do in production, and that's what I'm going to show you now. But if you ask me 6 months from now, this is not going to be my answer. All right, so let's start with, so think the gRPC is like, think of it as a remote procedure call, right? So you need to have a way where the procedure is stored and then just calling it from another function. So this gRPC interface is creating those stubs. So for that, I'm gonna like all this, these are the versions I'm gonna use, okay, 21. And this is the dependency, IOs or gRPC and service. So this is from gRPC, but tomorrow if you wanna implement, you can include Spring gRPC. And these are the stubs you need to create. And then Apache Tomcat, I'm using it. And these are all the plugins. So basically what it does is when I clean and compile it, let's see, I didn't create it, right? Okay, good. So it's gonna read from the compile and then clean install. Hope it works. So right now there is nothing in the target. So let's see what happens now. Oh, good. So it created a target folder. Let's look at the generated sources. Protobuf, gRPC Java, and all Starship. Ignore this greeting. This was just a test code. If I look in here, all Starship Java. So remember our method call? Like if I go back in here, all I need is get Starship info. If I go in here, there's going to be a function called get Starship info. And this is what you're going to call. So this is all generated code. And then if I look in here, so my version is okay, like com inside interface project, and then version number 1. So that's the first step. Create your protobuf, create a jar file exit with all the stubs in it. So that's the first step. And then the second step is you're gonna create. So there are 3 kind of interfaces. First is interface, second is the client, third is the server. So we looked at how the interface is. Now let's look at the server side. So now when I go back to my application.properties, gRPC, yeah. So in here, I'm saying, where is my form.xml? There you go. Yeah. So remember like how I defined it, I need to include this as a dependency as version 1.0. So that way we can maintain versioning. So in here, if I go to my interface, I have this interface project version 1, and that's what I'm including here. Okay, that's a step 2. And how you're going to actually implement it. Let's go inside gRPC server. It's the same thing, like all get Starship info. I'm gonna get, say, yeah, like, oh, like for example, like in the same way, when I go back to my interface, the function name is matching the protobuf, what I'm written it here. And then logic is going to be the same. Like, let me, okay, right, remove it, right? So I'm going to get the find all, and then I'm going to stream it. So for example, like I could just send like object here, but I want to show like the real use case of the gRPCs. You can actually stream it. You don't have to have everything in one place to start communicating to the server. So let's see it in action, for example. Like if in my client, what I did was, in the same way, again, in the client, I go back to my pom.xml. If I search for interface, I include this interface again. And then just for like, because it's difficult to invoke gRPC, what I created is just created a controller. All I'm doing is in get mapping, I'm just saying gRPC//ships. And then I get from the client. So this is a gRPC client. In here, what I'm doing is, and this is where I'm adding this gRPC client. So let's go one step further back. Sorry, I'm going all over the places, but like, okay, first step is what the interface. Second step was the server. Third step is the client. How do you know what server to connect to? So right now, because I'm running everything in locally, I'm saying, okay, this is my, like, remember like how you can specify OAuth and things like that. You can specify, okay, if you could have multiple gRPC servers if you wanted to. So this is going to be your key, local gRPC server. All you need to do is where is it running, what port is running, and then keep alive equal to true, and then keep alive without call. So even if I don't call, it'll still be alive. And then negotiation type, right now, to keep it simple, I'm keeping it plain text. If you want to be more secure, you could specify as TLS. If I go in here, it specifies TLS, plain text upgrade, or whatever type you want to. So those are the 3 steps. All right, so now let's go back to our demo. And we are running on time. What is my endpoint? I have 10 minutes left. Okay. Yeah. So gRPC/starships. I'm going to copy this. Oops. There we go. We got a 500. No error, no demo without 500. What did I miss? Oh, 81. This is running on a different port. And then I didn't start it. There we go. Hey, look, it already finished it. All right, so now it came back immediately. You were not going to see anything, any much of a difference. But let's do this. Let me add a quick sleep to show like how the real streaming works. So I'm going to go back to my server, gRPC server. I'm going to add a sleep, and then I'm going to restart. All right, so let it start back up. Okay, let me clear the logs, and then I'm going to go back to my client, clear everything. Now I'm going to request the same thing. And now let's look at the logs, how it works. Obviously, it's taking more time, but let's see what's going on in the backend. Let's look at the server first. See here, it's saying, OK, sent. Look at the time when it was sent. It was sent at 3/6/14/31, 32. For every second I'm sending. So that's the server side. It's visible. Now, if I go back to my client, like this, remember the names like 14/16/31, right? At the same way, when it says sent, I'm going to receive it right there. 14/16/31 is the same one. So you are actually streaming the data from the server to the client. You don't have to wait for it to, OK, I have all my Starship data. Now I'm going to send it to the client. No, the client doesn't have to wait for everything. As and when it gets, if I was like a smart UI developer, I could have shown it like as and when it's streamed. I didn't. I didn't do that. I'm still a backend developer. Yeah. Go ahead.
If you have a netty-based, it's a flux return. On the wire, it uses chunking, HTTP1 chunking, and it does the same thing. But it appears to be doing the same thing.
It's in the same thing, but like you could specify, like, for example, I don't have a way to show you, but like over the wire, the protobuf is pretty compressed. So you're not going to see the JSON or XML going back and forth.
In terms of
Correct.
streaming
Streaming already exists in Kafka and everywhere. It's not new, but like the amount of data you want to transfer back and forth, and you can keep the channel open. So those kind of things, you can still do it with gRPC. This is what? This is bidirectional stream, correct. You can't, the client cannot communicate back. All right, and this is all I had. We got 10 more minutes for any other questions. Yeah.
In production, where you
Oh,
That's stored.
deploy or some other sort of service delivery balancing mechanism?
I'm sorry, can you repeat the question?
Like you hard coded your port, right?
Yeah, yeah.
You know, your client's using for the service discovery mechanism or envoy.
Yeah, they are using server discovery. I mean, if you want to don't go that fancy, you could still have like a port number or like a environment plugged in. You could do something like that as well. Yeah. Before we go on, I think Ben has a few more slides to cover.
Yeah, and typically, if we're going to do like a multi-regional deployment, we'll host a lot of this in like a Kubernetes instance and do all that dynamic routing on in different means. Cool. Real quick, we'll just hit on a couple of client stories. So, we have a client here. Try not to say the client name. It's a client that focuses on distribution centers. So if you think about product coming in, let's say your Puma shoes and you've got tens of thousands of pairs of shoes coming into a distribution center for being developed all over the world. They come into a distribution center, they break down that cargo and then kind of send it out to all the retail locations, right? So distribution centers like your Amazon distribution centers, being able to maximize this is key to the to logistics around the world. Right? make sure we get product faster as possible. We have a client that builds conveyance and picking solutions. They also build a component called auto store that maximizes warehouse, and you'll see this Rubik's cube looking thing. They store it. If you have 100,000 square foot warehouse, it'll maximize the product and be able to automate this all through IoT or through through automation and robotics for picking and sorting products, right? We've been designing the next generation for this, and some folks like Amazon and others are really watching this project, and really revolutionizing like the way that you do distribution center automation and warehouse automation. It is the customer has thousands of clients, right? Instead of coming up with a single way of doing this, we can model this process, picking products, sorting products, that's going to be exciting. Climate you have, and then the data complex stuff. So you're integrating clients into this solution. Devices that are doing all this. Picking and sorting. Somebody brought this up earlier. It's like, hey, if you're building a very complex solution, right? You can use a multitude of these protocols or these frameworks from an API standpoint. Actually, communication staff. GraphQL for clients data, so they have different systems that will be large data. Schema that's exposed to every client sources being able to interact well. Also, we don't we were talking about it, but a lot of the devices on comparison had edge for Kubernetes on the edge to run up this, but integrating with how you're processing those devices on the edge. We're actually playing with gRPC right now. We were just talking about this, and this is part of variable management. Kind of those pickers, sorters, and those kind of things. So again, a very large, complex enterprise solution. Just kind of showing the case of like using multiple API frameworks, right, and solving that use case. Given time, let me jump to our next one real quick. This is a large manufacturer. Figured out who it is as soon as I talked about it. They have 30,000 locations across the globe. We've been helping to write their next generation point of sale system, as well as innovating on driving AI for the drive. So the baristas having to talk to you guys when you order your drinks. So all the automated. What was interesting is this client have a massive amount of footprint of stores across the globe. And what does everybody do in a coffee shop? They come in and they use what? The internet, right? They want to get access to the wireless. And what does all your little fun guys like you guys do when you access internet? You're going to try to break everything. Coffee shop here. So security is a lot of their solutions are point of sale. They're moving to a mobile point of sale solution, so the baristas can walk around to your car. You got the mobile app. You can order solutions, order your drinks. These are all very connected systems. So if you're in a coffee shop, it's name up here, but if you go into a coffee shop, try to do your mobile order. Watch how fast that order goes to the barista printing it. Right, that's a solution that my team wrote. Very, very fast, but it's all using gRPC. Now, using gRPC, the key here was number one was security. There's no endpoint system. But number two, it's all data that's serialized. If it was able to capture anything on the lines, or in any way, shape, or form, we can't see. So, unique use case, but something to kind of think about, as well as just the performance. They want a high performance metrics. So have a game. So cool. Just kind of want to tell the stories, but we have 4 minutes left. So let me open it up for any questions.
Yeah, the
we got.
slides and the source code, everything is over here.
Yeah. Level of maturity of a gRPC.
I would say it's still maturing. I mean, like it's not as robust as REST, but it is pretty there. I mean, they already support open telemetry. The gRPC supports open telemetry. So it is reaching there. I mean, you can see like clients are using in production level, but doesn't have that much support, that much to like community driven around gRPC yet, but it's still growing. Cool. Thanks you all for coming. I think we need to vacate the room for the next people. Thank you.
Like Starship and film are on different services. So like.
Yes.
You have it in one service, that makes sense to me. Very both of them get stitched together.
Mm-hmm.
What happens if you have Starship service, film service, other service, whatever, how do you still stitch them together?
Yeah, good point. So that's that beauty of GraphQL, right? I mean, everything hits to one endpoint, and you need to have like a gateway or somewhere in between.
So you use like Apollo.
Yeah, Apollo, where you can see what queries I'm returning, and then go to that service, get the query, and then return it from there.
Okay, all right, thank you.
Yeah.
If I have, let's say I have 100 microservices that a single API calls,
Mm-hmm.
that client chart, does that mean in my POM, I have to insert every single one of those microservices?
For gRPC, you're talking about?
Yeah, or if they all use the same method, can
I mean, it is a dependency. You still have to include in all your 100 microservices because that's the way it can compile. Hey, Josh, come on in. We are done. Yeah. Good. Yeah, it's all yours.
Yeah, well then,
Thank you.
So even if they all have the same exact entry point method,
Mhm.
they return